Good morning, good afternoon, and good evening. Thank you for joining Open Source Productivity Day on Google Open Source Live. If you haven't attended Google Open Source Live before, it's a monthly web series where each month we explore a different topic within open source. Today, of course, is all about productivity. My name is Faisal, and I'm an engineering manager at Google Cloud, where I lead engineering productivity for serverless and open source software.
Hello, everyone. I'm Aish Sundar, and I'm an engineering manager here at Google as well. And I lead engineering productivity for upstream Kubernetes and GKE projects. I cannot wait to co-host this amazing event today with Faisal, where we'll be covering all things related to productivity. Faisal, do you want to let the folks know what's in store for them today?
Absolutely. I'm excited to talk about the engineering productivity discipline, which is fairly unique to Google. It's not the same as QA or dev tools, but instead holistically focuses on accelerating engineering excellence at scale. I'm looking forward to showcasing some open source tools and processes that we also use internally. We'll kick it off with a talk from Eric Feda to walk us through enterprise productivity on an open source budget. But before that, we have a couple housekeeping items.
Yep. Don't forget to leave all your awesome questions at the live Q&A forum, which you'll find below the live streaming window. Our speakers are here ready live to answer all of your questions. However, if you're watching this on full screen, you might want to exit that mode to see the live Q&A forum. Our event has been pre-recorded to allow for accurate transcripts. However, as I said, our speakers are here ready to answer all your questions. After the event, feel free to join us for an amazing after party. You will find the button to join that in the events page at the end of the last session. And last but not the least, feel free to use our handle Google OS Live to be able to share your experiences in the social media channels.
Awesome. Thank you, Aish. With that, Eric, take it away.
Hi, everybody. My name is Eric Feda, and I am here with the engineering productivity team at Google. And we get to work on some of the tools that help communities like Kubernetes, Istio, and Knative stay productive. I'd like to talk about two of these tools that we work on today, Prow and TestGrid. So Prow is an eventing system that lets you do important activities like continuous integration testing and continuous deployment using some common patterns like GitOps and ChatOps. TestGrid, on the other hand, is a way of visualizing your current and recent test results. This sort of makes it easy to detect patterns in your testing that you might want to investigate further. We're going to talk about both of these tools, of course, and hopefully I'd like you to sort of see what they look like, see how they're useful, understand how we develop and maintain them, and maybe try them out yourself. So let's start with TestGrid. You can see the code for TestGrid over at Google Cloud Platform TestGrid in GitHub, or you can go to testgrid.k8s.io to see our public deployment. When you go there, you will start off by seeing a dashboard, sort of a grid of different dashboards that you can go to, or potentially a group of related dashboards. When you open one of those groups, you will first start out with a summary of that group that's sort of showing you all what's been recently happening with each of those dashboards. Open up a dashboard and you'll get to the summary of all the different tabs of testing that are happening on your dashboard. When you open one of those tabs, you'll get to the grid, where you'll see rows of testing flowing down and columns of results flowing to the right. The cells are colored based on whether they pass or fail, with green meaning pass and red meaning it failed, and maybe if something interesting happens, it'll be another color. This sort of, is the ideal state. Obviously, most likely you'll have more tests, and this will make it hopefully easy to see sort of some interesting patterns that happen. Like here you can see that there is a regression in some disk testing in November. Or it might be, get considerably more complicated over time. The way you declare these jobs is with sort of a YAML document. We find this to be a really easy pattern that's for people to understand, which helps teams onboard quickly, which we like because it feels good for the team to sort of be able to onboard quickly without having to wait for us to explain things to them or give them permission. And the time we're not spending helping supporting these teams is time we can spend making the next version of TestGrid even better. So here's what this definition looks like. You define one or more test groups that reference a Google Cloud Storage path. And inside of that path, you will have each column is represented by a monotonically increasing number that sort of acts as a directory. And inside each of those directories, you'll have some metadata, like a started and finished JSON file that specifies what was checked out, how long it ran, whether it passed, those sorts of things. And optionally, some JUnit XML files that give you more details about exactly what testing happened and the results during that build. Once you have your test groups defined, you then have to put them into one or more dashboards. And typically, each test group will only have a single tab, but you actually can have you can have a test group be referenced by multiple different tabs. This can be useful if your testing is owned by multiple teams. So for example, in the Kubernetes community, we have a lot of large end-to-end tests that tend to be we sort of tend to deploy a cluster once and then run everybody's tests inside that same cluster. But individuals tend to only be interested in a particular sub area of Kubernetes. Like maybe one person's interested in the storage features and another person's interested in the networking features. So we'll give them a sort of view that pairs down the testing to just the storage or just the networking tests. Maybe a third that has all of them for when that is important. There's a lot of different ways to configure TestGrid. You can look at our documentation that sort of gives you all the different knobs you can tweak to make sure that your grid looks exactly the way you want. And so, a lot of the stuff you can configure, you can declare in your configuration, but then there's also a lot of flexibility at runtime. So for example, there's the size drop down to customize the width of each cell or column. And then there's the option drop down that will let you filter down to just the tests that are relevant to whatever you're investigating at the moment, or maybe group them into some kind of hierarchy, or maybe change the sorting to highlight particularly flaky tests. If you have numeric data, you can graph that and potentially see interesting patterns there that have been happening. Like maybe there's been a recent performance regression, and you can sort of figure out exactly what commit or when that happened. So as you configure things, that information gets bubbled up into the summary. So this will highlight tabs that it thinks are broken, or sort of give you all sorts of interesting information, and this will help you optimize figuring out where you should be investigating your time into looking into what's happening with your system. So we talked about how the declarative YAML pattern is helpful for people, is helpful for us, keeps us and them productive. Another thing that helps us stay productive is using Kubernetes, which is where we deploy TestGrid into, and in particular using GKE Autopilot. So this is a new way of running a Kubernetes cluster that sort of makes all of the nodes invisible to you. So we really like this because it frees us from having to worry about exactly how many VMs we want to use, or what OS they're running, or how many CPU or how much RAM to put on those VMs. Instead, we can just declare that in our deployments. We can specify like how many replicas we want, how much RAM and CPU these jobs require, and GKE Autopilot makes sure that the cluster is sized appropriately to handle my jobs. This is really great because we don't really want to be, all the node management is sort of hassle that we don't want to have. And so it's been really nice not having to worry about that. Another thing that helps us be productive is, of course, Prow. So so we use Prow in all sorts of different ways. We use it to test new changes that come in to make sure that they're not regressing anything. We also actually use Prow to merge our tests once they've been, or merge our changes once they've been reviewed and passed testing. We use it to publish new images and also upgrade our production environments with those new versions. So let's see how that looks. You can look at the code for Prow in the Kubernetes Test Infra repo on GitHub, in particular the Prow directory there. You can look at one of the public instances at prow.k8s.io, or you can see a bunch of other ones in the README. Prow sort of came out of the Kubernetes community, and you can see that, its influence in a lot of the design decisions that Prow uses. So one thing that's a pretty useful and powerful feature about Kubernetes is that it has custom resources, which allow you to extend your Kubernetes cluster with new types of objects to manipulate. So instead of just having the services and deployments that come with Kubernetes by default, we can also add so Prow sort of extends it by adding a Prow job resource. So this is showing you how that is declared. The interesting thing about that is it becomes the pattern, like sort of the Prow job becomes the sort of glue that all the different components of Prow use to communicate with each other. So they communicate by reading from and writing from a Prow job via the API server rather than talking to each other directly like an RPC. So this sort of creates like a loose coupling of the system that allows for a little bit, that allows for more flexibility in terms of how we deploy and maintain the service. So for example, there's less availability restrictions since one component isn't talking directly to another component. If there's a brief outage of the other component, that doesn't prevent the first component from working. If you look at the history of Kubernetes design, you can see that it tries to be tries to be inspired by jazz improv, where you have a bunch of talented performers that are following some rules to create interesting music, but there's no central coordination like you would have in the symphony orchestra, for example. To see this working in action, if you want to do some testing that's going to, in response to some GitHub event, that'll use the hook component. So hook is going to be receiving your webhooks from GitHub, and then it will respond to that by creating a Prow job. And it does that by talking to the API server. Then the Plank component it's sort of watching and listening for new Prow jobs. And when the API server tells it about a new Prow job that exists, Plank is then going to read the config and create the corresponding the corresponding pod to complete that job. And then it'll update the Prow job status to, when the pod starts and finishes, to let everybody else know what is happening there. So with pre-submits, so to do pre-submits with this, you're first going to need to configure the hook plugin, configure the trigger plugin on Hook. Hook has a bunch of different plugins that you can look at. Sort of encourage you to take a look at the different plugins that we already have built into Prow, or if there's some new thing that you would like to do, you can write your own plugin that satisfies that. And then once you've enabled the plugin, you then declare your jobs in YAML, sort of to specify what happens. So let's take a look at what one of those looks like. Here is the pre-submit for test grid, and you can see that it's sort of divided into two sections. The top section is mostly about the triggering, specifying when the Prow job should get created. You can see that it's targeting the test grid repo, and that it's a pre-submit, meaning it should run before code merges, and it's sort of targeting the master branch. Then on the bottom, you have the Kubernetes pod spec. So another interesting aspect about Prow is that it sort of uses pods directly. Like it doesn't have its own runtime environment. It just creates the pod that you specified and waits for that to complete. So it really expects you to understand how Kubernetes works. So all the knowledge that you have about Kubernetes already, you can transfer into writing your Prow jobs. Or conversely, if you're using Prow to gain new expertise about Kubernetes, all of that will transfer to the other ways you use Kubernetes. But the sort of really simple version is that you need to have a container, and that container will specify a Docker image that provides its runtime environment with all the dependencies your testing needs. And then there's a command that'll be run inside your container. And so Prow expects your command to exit 0 if your testing is successful and exits non-zero if something failed. So another couple of things that help us be more productive is workload identity and decoration. So if you notice, when we declared the pod, we specified a service account to use inside of this job. And workload identity is a GKE feature that allows us to annotate the service account, telling GKE who we want this service account to authenticate to GKE as. And this works really great for us because it allows our code inside our testing to not have to worry about authentication. It kind of just happens automatically in the background via workload identity. And so we can just have our testing, focus on testing, not have to worry about authentication. The other thing is decoration, which is telling Prow that when it creates the pod, it should inject some init and defer containers. These containers sort of run before and after your test containers, and they'll do some common boilerplate work, like making sure that all of your repos are checked out at the right commits. And then it'll also upload the metadata about when it started and when it finished. And it includes a artifact volume where you can copy all of your JUnit XML files into. And Prow will make sure Prow will make sure in the defer container to copy all those up to GCS. So for things like publishing images or upgrading our cluster, we're going to want that to happen after merging code. So that's going to be a post-submit job, and this sort of gets into the GitOps side of things. But aside from but otherwise it's really very similar to the pre-submit. Here's what it looks like. Instead of a pre-submit, it's a post-submit. But otherwise the trigger is very similar. This is just saying that we want it to run after we merge code. And then if you look at the pod, you can see that it's also very similar, but we've provided a slightly different image to use and running a different command. And also see that we're using a different context. Since this is pushing images that we intend to use, we want it to run as a more trusted user. So we have a different service account. We obviously don't want our pre-submits pushing images. And then we'll also have the ability Prow has the ability to schedule the pod into different contexts. It can be a different namespace, or it can even be a different cluster altogether. Yeah, so that sort of is how pre-submits and post-submits work. If your testing needs to run according to some kind of schedule, like a cron job or whatnot, that will be handled by the horologium component. And so obviously everybody knows that the horologium is the clock constellation. So once we publish new images, we need something to notice those new images and upgrade our cluster to them. So we use a periodic job for that. And you can see here we're scheduling it to run on a hourly basis during working hours. And then let's see, you sort of provide the configuration about under what types of images it should be bumping, and then this will run and then notice find any new images that exist, and then automatically create a PR to update our images to use the new versions. It's kind of nice because it makes it really easy to see what changed in our images between the last and current version. And then once we've approved it and merged it, we now need something to actually deploy it to production. That's going to be and so we're going to use another post-emit job for that. Looks largely the same, just with a different image. Yeah, but otherwise just another post-emit. So great. So sort of in summary, we sort of showed you how Prow, how we use Prow to test TestGrid, publish it, publish new versions, and then upgrade our cluster. Then we also talked about how TestGrid can help you visualize testing that has been happening recently for your system and find interesting information. If you are wanting to try either of these things, you can go to our Getting Started Deploy documentation for Prow, and then look at the standalone TestGrid documentation. If you go to this link here, the testgrid.k8s.io/r/knative-own testgrid, you can see an example of what this will look like. We also have contributing documentation. If that kind of thing is interesting to you, we'd love to hear from you, or yeah, and so please feel free to reach out to us. You can contact us either via Slack or GitHub. And yeah, so that sort of concludes my presentation of Prow and TestGrid. And so thanks for joining me, and have a great day.
Thanks, Eric. I'm amazed at how powerful and flexible Prow and TestGrid are for running CI and visualizing the results. Next, we'll hear from Benjamin Elder and Amit Watve, who will be talking about Kubernetes testing with KIND and Kubetest2. Let's roll the tape.
Hello everyone, welcome to our talk. My name is Benjamin Elder and this is Amit Watve. We'll be speaking on Kubernetes testing with KIND and Kubetest2, two tools from the Kubernetes testing special interest group. What is KIND? KIND is Kubernetes and Docker. It uses Docker containers to simulate Kubernetes nodes. So instead of a virtual machine or a physical machine, we use Docker containers. And this allows us to run pretty much anywhere that you can run Docker, be it in various CIs, locally on your workstation, wherever. It can run multi-node clusters by running multiple containers and wiring them together. It can run IPv4, IPv6, or dual stack clusters, which is a little unusual. It can build and run Kubernetes from source, which is very important to us in the Kubernetes project for developing Kubernetes itself and where this project originates from. And on a machine with everything pulled, warm, hot, ready, it can boot a cluster in 30 seconds or less, which is pretty awesome for development. So why KIND? Well, for testing Kubernetes, that's why we built it. For testing applications and controllers, which we figure probably what most of you are interested in. And for bootstrapping cluster API clusters, where the clusters themselves depend on tooling that runs in Kubernetes to create clusters, and it's turtles all the way down. So KIND makes a great bottom turtle because it's very simple, lightweight, and easy. You can run a KIND cluster, install your cluster API controllers, and create a cluster API cluster. This is something else we support. So how does it work? Well, as I said, we create node containers. So you can see here you have Docker running on your workstation and the KIND command line, which is talking to Docker. The KIND command line will talk to Docker and tell it to create node containers. These node containers are going to run a number of little tricks and get systemd, kubelet, containerd, all of the Kubernetes components from core DNS, kubeproxy, etcd, kube controller manager, kube scheduler, kube API server, and anything else that may become a future system component running. This uses kubeatom, which is a fairly standard tool within the Kubernetes project for doing machine bootstrapping. And then it will also run your user containers nested here, and kindnetd, a small networking daemon we implemented for very lightweight implementation of Kubernetes networking and CNI. So it keeps everything very nice and lightweight. It's pretty straightforward. It's like Docker and Docker, if you're familiar with that. It has some additional things going on, but it's pretty much the same concept with nested containers. So I said Kubernetes and Docker, but we also have Kubernetes and Podman. I'm going to call it that. We like the KIND acronym, a little easier, but we have Podman support now. You can use Podman instead of Docker, which is pretty nice for users in the Red Hat ecosystem in particular. It also supports rootless now, Podman or Docker. Shout out to Akira Suda for working on this in the upstream community in Kubernetes and Podman and Docker and KIND in particular. This is some pretty cool work that has landed recently to enable this throughout the entire ecosystem. So if you have rootless installs, everything should just work now. And in the future, we may consider supporting additional runtimes as we see demand. But for the moment, Kubernetes or Podman. So not just Docker. Installing KIND is also pretty simple. You can go get it if you're familiar with that as a Go developer. You can brew install it if you're on using Homebrew on Mac or Linux. You can use Mac ports or Choco if you're on Windows. We also have release binaries on GitHub, and our docs have more information about how to install from the release binaries or any of these options. You'll also want to install kubectl, which we will point you to the upstream docs for the Kubernetes command line for interacting with your cluster. So to create a KIND cluster, you call KIND create cluster. That will get you a single node cluster with the default settings. It will be named KIND, and it won't have any fancy options. It's a single node, and it will default to a recent Kubernetes version. You can add a name, and instead of naming it KIND, you can call it something else. Here we're calling it cluster 2. Doing this allows you to create as many clusters as your machine can handle before you start running out of resources. It varies quite a bit depending on workloads and things. So we don't have any hard rules for this, but if you give them different names, you can create as many as you want, and then just use that name flag with the other commands to let it know that you're not using the default cluster. I find most of our users just use the default cluster, but once you start to get more advanced, you might want to do multi-cluster testing or have different clusters for different things you're doing. So pretty handy option. For more advanced usage, we support Kubernetes style component config. So we have configuration docs here, but basically it's like Kubernetes component config. You need to set an API version and a KIND. The KIND is cluster. The API version is an experimental one, depends on the KIND version. And you can use this to set all sorts of things about your cluster. So some examples, you can enable Kubernetes feature gates across all the components. So in this case, we're enabling the CSI migration feature gate. So you can test that, install your CSI drivers, make sure that it works. It's only a few that are going to work on KIND, but there's many more feature gates like this that you could enable or disable, including default feature gates. And on a related note, you can disable or enable in the runtime config the APIs at this level. So a pretty common thing that you might want to do is disable, say, beta APIs and make sure that your cluster is not using that. You might also want to do alpha. So you could disable alpha, beta APIs, make sure that your tests are only using GA features that are going to be available everywhere. You know, maybe you're using K3S in some places or something, so you don't want to depend on any alpha or beta features. We use this in Kubernetes upstream. We do conformance tests and make sure that they're not depending on non-GA features, so it's easier for providers to meet this. So it's a really cheap and easy way to toggle features and functionality in your cluster. We hope this is very easy to use. And there's more docs on this on the site. So when you're doing this, when you're testing with KIND, a typical flow is pretty straightforward. It looks like this. So you're going to create your cluster with KIND create cluster. Then you're going to build your application, your images, your Docker images, whatever your app needs. Once you're done, the most common thing people do is use KIND load Docker image. So that's going to take your image from Docker. It's going to export it as an archive. And then it's going to sideload it into all the nodes, containerd, container runtimes, and make sure that that image is available for them to run with without need for the internet. So it keeps everything nice, hermetic, and local, self-contained, easy to work with, no external dependencies, no problems if your registry goes down. Alternatively, you can push to a local or a remote registry, and that will work fine as well. We have some more docs about how you can integrate a local registry. But most people are going to use the loading. Loading has some other nice properties, like you don't need to rename your images to go to the special testing registry or something like that. You can use your production image tags because it's never going to be pushed, just load directly. Then you run your usual end-to-end application tests, whatever those may be. So in the Kubernetes project, those will be Ginkgo tests. And then after you've run your tests, we have a handy little command, KIND export logs, that will allow you to get all of the system logs from all the nodes and all the details about the cluster that you can use to debug that sort of thing, or bring to us and tell us, hey, we found some problem with KIND. Here's the system logs. These are pretty handy to capture. Highly recommend this. After you've captured the logs, you can delete the cluster. For all of these commands, if you've used a different name, you just add the name flag. So KIND load Docker image, KIND export logs, KIND delete cluster. Just pass the name of your cluster. You can also do this with an environment variable. We have more details on this on the site. So you might recognize this flow as being pretty familiar, and a little bit here when Amit talks to you about Kubetest2, another tool that we use for testing Kubernetes that you may also find useful for testing your own applications.
Thanks, Ben. Hi, everyone. I'm Amit, and I'm going to go over another tool that we use in the Kubernetes project called Kubetest2. So Kubetest2 is a framework for launching and running end-to-end tests on Kubernetes, and it is intended to be the next significant iteration of kubetest. Kubetest v1 is the framework that we use currently in the Kubernetes project for continuous integration testing, or CI, and runs about thousands of jobs daily. It comprises of a single binary encompassing all the different combinations of environments and scenarios that we test in Kubernetes in CI. It evolved organically from a bunch of legacy scripts, and in some cases literally from shell scripts, to the point where it's starting to become a bit unmaintainable. Which is why one of the primary goals of why we created the Kubetest2 framework is to move away from legacy dependencies and to build something that is more easy and extensible. So what are the primary features that Kubetest2 provides? The number one feature that Kubetest2 provides is consistent cluster lifecycle. A typical testing flow for Kubernetes looks like building some binaries from your change, deploying the cluster, running some tests against the cluster, and then tearing it down. In Kubetest2, we have standardized and codified this lifecycle to make it easier to enable different testing workflows that you might have. We will go into some more detail in the upcoming slides. The next thing that Kubetest2 provides us is decoupled deployed implementations. So Kubernetes comes in multiple flavors and offerings, be it distros, installers, providers, and in many cases you want to run tests against at least a few of these deployers. So Kubetest2 provides a way to not only run your tests against these different deployers, but also allows you to extend the framework to include your own implementation of Kubernetes. Alongside deployers, we also provide support for plug-and-play testers. So plug-and-play testers allow you to run different kinds of tests in a very user-friendly way, in a plug-and-play fashion, where you can be it your own application or any other test that you're planning to run against the Kubernetes cluster. One of the key features that we wanted as part of the Kubernetes developer lifecycle itself was being able to run CI testing jobs locally with as much hermetic reproducibility as possible. And as part of our goal to minimize legacy dependencies, we provide a unified command line interface to be able to reproduce the system under test in both CI and local environments as closely as possible. Lastly, Kubetest2 also integrates seamlessly with other tools that we use as part of the Kubernetes project, one of them being Boscos. Without going into too much detail, Boscos is a tool that we use in Kubernetes CI for leasing testing related environment dependencies or resources at runtime. Most canonical example being renting a clean Google Cloud Platform project for the duration of the test to run tests against the GCE cluster. Now let's take a quick look at the architectural overview of Kubetest2. As mentioned earlier, a typical flow is broken down into multiple phases. We start with the build phase, which is mostly an optional phase and which we most preferably use in the developer lifecycle upstream. And in this phase, we build Kubernetes artifacts from source, be it the actual Kubernetes binaries or the integrated upstream end-to-end test binary, or other tools like the kubectl CLI itself, which you would want to use to interact with your cluster. Then comes the up phase where we actually deploy a cluster. In addition to being able to deploy your own flavor of Kubernetes, we also support a bunch of standard Kubernetes providers that we use in upstream testing, be it GKE, GCE, KIND that we all heard Ben just talk about, or Kubernetes operations or COPS clusters in short. Then we have the actual test that we want to run, or the test phase. Canonically, we use the Ginkgo framework upstream for running the end-to-end test binary itself. In addition to that, we also have a few frameworks specifically for testing Kubernetes node and scalability of the cluster. Or apart from these canonical test frameworks, you can also test with your own application or controller, or it can even be a simple shell script that you want to exec against the cluster. And lastly, we have the down phase where we tear down the cluster, cleaning up the testing environment, also releasing any testing resources that we might have rented from Boscos. Now let's take a quick look at the actual command line and how it looks like. So Kubetest2 uses the binary plugin mechanism for detecting plugin deployers and testers. The binary plugin mechanism is used widely across the project, including kubectl itself. The way it works is that binaries are named in particular standardized format. In this case, kubetest2-your deployer would be used for your deployer binary, and kubetest2-tester- your tester name would be used for a kubetest2 tester. And the actual command line invocation looks something similar to what kubetest2 deployer, your deployer name, --build, --up, --down, specifying the phases of the test that we want to run, followed by any additional deployer args that you want. In addition, you will also specify --test, the tester that you want to include, and then followed by any of the tester arguments that you want to provide. And here we have a quick example of how we run upstream CNCF Kubernetes conformance tests against a GKE cluster. So thank you everyone for listening to our talk. Both KIND and Kubetest2 are part of the Kubernetes project and are sub-projects of the testing-oriented special interest group, or SIG testing as we call it. You can find links to both the projects as well as our community page as shown here. And we are always welcoming anyone wishing to join the community. So please feel free to join us. Thank you.
Thanks, Benjamin and Amit. Wow, an entire Kubernetes cluster bootstrap in under 30 seconds? That's pretty rapid and on fire. And who doesn't want unified cluster management across deployers? Yay for productivity. Okay, then next up, we have Benjamin Coe, who's going to be walking us all through reasons of why we should release early and often. Take it away, Benjamin.
Hi, my name is Benjamin Coe. I'm going to be giving a talk today about some open source software that my team wrote to help us better release our libraries early, release our libraries often, but has also helped us make sure that this isn't our full-time job. As I said, my name is Ben. You can find me on GitHub at github.com/bcoe. I love open source software and contribute mainly to the JavaScript community. I have made quite a few contributions to Node.js, where I'm part of the tooling working group. We do a lot of work around the file system, so things like recursive copy and recursive remove. I've also made contributions to Chromium, the web browser, and personally work on the libraries Yargs, which is an argument parser, and C8, which is used for test coverage. I was the third engineer at a company called NPM Incorporated, which is the company that for years supported the NPM JavaScript registry. This is where I really got interested in the releases and in releasing artifacts, and also in open source software, really. I today work on a team at Google that releases client libraries for over 100 Google Cloud Platform APIs. And these are, by this I mean APIs like Cloud Storage, our ML APIs, Secret Manager. So these are client libraries so you can build products yourself on top of these APIs. So I'm going to be talking today about releasing software using an open source tool called Release Please. So to give you a little bit of an idea of what the agenda will look like, I'm going to talk first about client library releases in general, a bit of a primer. I'm going to talk about the problem my own team was facing around releasing our client libraries. I'm going to talk about how we brought structure to a little bit of the chaos our team was facing. And finally, I'm going to introduce the tool we built to help with this process, Release Please, and kind of summarize the talk. So for starters, what are client library releases, and primarily how do they differ from other types of releases? For instance, releasing a web service or releasing your website. So when I talk about client library releases, I'm mainly talking about the idea of taking an artifact, it's usually a tarball, and putting it up to some registry, such as Maven Central for Java or NPM for JavaScript, Ruby Gems for Ruby, Composer for PHP, NuGet, PyPy, etc. For some languages, this might also just be the act of tagging an artifact on GitHub. I know Go used to work like this. And basically what this means is it's taking something like a GitHub repository where your team works on code, and it's turning it into a point-in-time artifact that's released to a customer. And what's kind of interesting about client library releases is your customer often then has their own users. It might be their own end users. So it might be that someone's using you as a dependency to build a website, which is then used by a large set of customers. So I have a quote here from Isaac Schluter, who's the person who wrote the NPM library originally for the NPM registry. And it's a good framing for how library releases are a little bit different than other types of releases like a website or web service. And to quote him, an OSS library that has not had a single update in several years might be more well supported than one that gets an update frequently. Code that is simple and widely used by active maintainers has a potential to reach a done state very quickly. I think this is a good framing for one of the major things that's different about client library releases. Let me go into some more details about this. So here are some ways that I think client library releases differ from, say, a web service or a website. As Isaac points out, they do have this potential for reaching a finished state. Updates to a mature library may approach zero over time. In general, though, release frequency may be less than other types of products like a web service. Your customers are much more active versus passive. So whereas a website, a new stylistic change might go out and it doesn't have a huge effect on the end users other than maybe they find a button more easily. If you release a version of your client library, it's good practice for your consumers to in turn make sure they're up to date on the newest version of the library. And in turn, these updates to your library can create work for your consumers. Too many updates, especially breaking changes, can lead to frustration and fatigue. Client library authors saying, why the heck is there another release of yards this week? I just updated a week ago. This is the kind of mentality you want to avoid when you're releasing client libraries. Furthermore, because consumers are having to update their libraries in result to your updates, consumers need actionable information about an update, i.e. a good changelog. What changed in yards this week that makes me need to be able to take this update? As I alluded to earlier, your customers' customers are your customers. This makes libraries fairly susceptible to a type of security attack called a supply chain attack, where someone can target your library in an effort to target the end user of that library. So say that you are releasing a library that's used by someone to build a site that's delivered to a Fortune 500 customer. It's important that your library follow good practices such as automated releases, providing detailed release information, such that there's actionable information for the upstream consumer to make sure that this is an actual update to your library and not perhaps a malicious update to your library in some sort of supply chain attack. So in this way, I think client libraries differ from releasing a web service. So to summarize a bit, client libraries might not be released as often as some products like websites, which might actually release several incremental changes a day. It's actually fairly often that a web service might deploy 4 times a day as each patch goes into it. However, even though client libraries aren't released perhaps as often, each release is potentially more time consuming. Consumers need actionable information about why they're required to upgrade their dependency for security reasons and just for quality of life reasons, making sure they don't break their own software. So having talked about the problem of client libraries and releasing client libraries in the general sense, I want to talk a little bit about the actual problem that my team at Google was facing. We have to release a lot of client libraries. My team supports 7 languages: Node.js, Go, Python, .NET, PHP, Ruby, and Java. And each of these languages has their own client libraries they have to release. The client libraries we're releasing are in support of 100 GCP products. These include products such as Cloud Storage, Compute Engine, Secret Manager, PubSub. All this said, over the last couple of years, my team has grown from having to release client library updates maybe a dozen times a month, or 50 times a month at most, to having to release approximately 1,000 updates a month. So before we started building this automation tool that I'm going to talk about a little bit today, creating releases for a client library was a very manual process. It took a minimum of 15 minutes per release. If you look at today, where we're doing 1,000 releases a month, this added up to about 6 full-time engineers would need to be doing client library releases each month to just get our releases out the door. But this is the only problem. Humans are fallible. We missed documenting important changes, released features as patches, missed breaking changes. In general, the process was breaking down a little bit. We knew that we needed to automate this. Here's the problem. This was about the quality of pull request we had from our upstream API builders a couple years ago, because we had no real standardization. So we'd get this change in, which would have an update to our client library. The only context we had was that there was an update and it was to a specific API, in this case, phishing protection. We needed a better way to know what change had come from the upstream API producer. So in effect, we needed to find a way to bring a structure to this kind of chaotic information we were getting. So what we needed was a common language that folks rating these upstream APIs and folks releasing the libraries could use to make sure that we provided contextual information to our library consumers so that they could actually build things on top of our libraries. As I said, we had no way of understanding the nature of the upstream changes. And we had to put a detective hat on each time to, we just had to look at code and see what had changed in the code, and then use this to try to describe what the change might actually be. We weren't good at identifying when a change was breaking. We didn't know what exactly it fixed. We didn't know if it was an exciting new feature we should introduce to our customers and kind of call out for our customers. So we had an idea for how we would start to bring structure to this chaos. There's this convention called conventional commits, which you can find at conventionalcommits.org, which describes a language one can bring to the commit messages they're writing to provide the context we were looking for from the API producers down to building these client libraries. So we started looking at conventional commits. Ultimately, we really identified that there were 3 main things that we wanted to draw attention to for our customers. We wanted to tell people when a fix was happening, and this indicates that a bug has been addressed in the library. We wanted to indicate to users when a feature had been added. Conventional commits allows you to do this with the prefix feat. And we wanted to more accurately indicate when breaking changes were coming through for our customers. So this was what the pound symbol indicates. It says that this change is breaking and should be a major update to the library. Conventionalcommits.org describes a variety of other small nuances to how someone should write conventional commit messages. But these were the 3 that we felt were most important for the problem we were trying to solve. And these were the 3 we evangelized to people working on these libraries. So if we take a look at the screenshot on the right here, you can see what commits look like to our code base as we started to adopt these conventional commits. The important thing that might jump out here is the fix, which says we fixed a bug down there towards the bottom. And the feature we introduced towards the top, feature in Secret Manager users can now use filter to customize ... So it wasn't too hard to start to convince people that this was better than the noise that we had in the prior example. There's another really lovely thing about these conventional commit messages, though, which is that they correspond very closely to this concept of semantic versioning. Semantic versioning is the idea that if you have a version number for your software, so 1.0.1, the least significant digit is updated when you're creating a patch release. The middle digit is updated when a new feature is added, and the most significant digit, the one on the farthest left, is updated when a breaking change is created. So what's really nice about semantic conventional commits is that it lines up very closely with semantic versioning. So let me show you what I mean by this. If we have a commit of the form fix foo, this is indicative of the fact that a patch is happening. So we update the digit farthest to the right. If we have the conventional commit feat, we know we have to update the middle digit. And finally, if we have an exclamation point on any type of commit, a feature or a fix, it's indicative of the fact that we now need to update the leftmost digit, and it's a major version of our library. So not only do we get more context about what's actually changed in a library by adopting these conventions, we actually have a better idea of what the next release of the library should be. So ultimately, to kind of jump to the chase a little bit, we've started to find that this language was working for us. Adopting a small amount of extra process allowed us to much better understand the software we were delivering. So this was great. And we did start to see adoption upstream. API teams were able to adopt this convention, and there wasn't too much complaining. For the most part, people understood that this would benefit the customers. But wait, there's more. The nice thing about this was we now had a structure that a machine could also learn. And we were in a position that we could actually start to automate our release process. So what I'd like to introduce to you now is the tool we wrote called Release Please, which is what we've been using to automate our client library releases based on these standard commit messages. So what is Release Please exactly? It's an open source tool that can be found at github.com/googleapi/releaseplease. And essentially, it parses conventional commit messages and proposes release PRs. You can see it on the right here, kind of going through the process of analyzing the commit history and opening something we call a release PR. What is a release PR? It's a PR that's kept up to date with the changes that would be included in the next release of your library. So if we take a look on the right here, we don't release a new version of the library with each new update that happens. We keep this release PR up to date, and it might include an entire collection of things that are going out to the customer. So in this example, we have a feature that's going out to the customer, and then we have a few bug fixes that are also going to go out to the customer. The other nice thing it does is it proposes what the next version bump will be for your library based on Semver, taking into account the fixes, features, and breaking changes. So in this case, we have 5 bug fixes that have happened in a single feature. The most significant thing takes precedence, so we're going to update it from version 17.0.0 to 17.1.0 in this specific example. Some other nice things that Release Please does for you is it maintains a human-readable changelog, and it also updates all the language-specific files that reference the version number, such as setup.py, package.json, composer.json, cargo.toml. And here's an example of that happening in the right hand here. We can see that it's updating not just a changelog at the top, but it's also updating the package.json to be what this new version would be if we were to release this. So why did we go with this approach of a release PR versus, as I was saying, a web service might just release everything that lands on the main branch throughout the day? Well, it allows us to control the next release that goes out with more granularity. Perhaps it makes sense to release several changes in conjunction. Like there's a feature that relies on actually 3 components to land. So rather than kind of having to land each thing all at once, rather than having to land each thing individually, you might want to collect them up in a release PR and then land that release PR all at once. Another reason for my team is we generally try to avoid releasing things on Fridays. So by having this idea of release PRs, if you happen to land a bunch of work on Friday, we can just keep that release PR open and then release the software on Monday when we're ready for it to go out. Another advantage is it reduces this concept of update fatigue, where you don't necessarily want to give your customer hundreds of new library versions each week. It might be nice for them to get one version each week. In general, it just allows for more coordination. Major releases can be treated differently than minor releases, as an example. So what are some of the features of Release Please? Well, it supports many programming languages such as Python, Rust, Node.js, PHP, OCaml, Ruby, Helm. I don't even think I've named all of them. So regardless of your language of choice, Release Please actually supports it in many cases. It supports monorepos. So if you happen to be releasing many libraries from one repository, Release Please has fairly good support for this. It maintains a lovely human-readable changelog for you, handles bumping version numbers based on Semver, as we discussed. It creates the corresponding release on GitHub. So this is just the idea that you create a tag on GitHub and it has something similar to your changelog attached to it. Perhaps most importantly, it's open source. Many of these languages, such as OCaml, were actually contributed to us by external contributors. One thing Release Please does not do is it does not actually publish to the package registry like Maven or PyPy or NPM. We decided this, how this works differs significantly on a language by language basis. And we decided that we would leave that to the next step, which people can rate independently. So we decided this wasn't our responsibility. Just going back, I just wanted to give a brief example of what the lovely changelog looks like. So it's a nice markdown file. It includes links to the actual issue that was closed. It will contain links also to the users who contributed changes if you happen to reference them. So something that something that a person consuming your library can actually come and use to determine what steps they need to take to upgrade to the next version of your library. So a little bit of an epilogue. Has Release Please actually benefited our release process? Yes, it has. We've grown from about 20 libraries when I started on my team to releasing for about 100 libraries at this time. In that process, our releases have grown from perhaps a dozen a month to greater than 1,000. I think if we didn't have this automation in place, people would have grown very fatigued of the amount of time they were spending handling releases. And furthermore, as I said, I think just in terms of people hours, it would have taken at least 6 people a month to do it. So one of the other things that I thought was really great about Release Please was we showed that we were able to entice teams to adopt some simple conventions if we could show that it was beneficial enough to them. So why were people willing to adopt these commit conventions, even though it can be a little pedantic? Because it gave them fully automated releases with changelogs and semantic versioning. And also it's compelling that we're saving thousands of people hours each month. So in conclusion, you can try it out today. We already have lots of folks outside of Google using this software. You can find it on github.com/GoogleAPI/releaseplease. Thank you. And it was a pleasure to be able to present this to you today.
Thanks, Benjamin. Listening to you talk, I really got a sense of all the wisdom and experience that inspired the Release Please tool. At this point, we've learned about setting up continuous integration, leveraging powerful test tools, and establishing a structured release process for open source software. But how do we measure all this productivity and progress? Next up, Dina Graves and Sofia Vargas will talk about what velocity means in OSS. Over to you.
Hi, I am Dina. I am a developer relations engineer with Google Cloud. And our talk today is measuring DevOps. What does velocity mean in open source? And specifically, we are going to be looking at the DORA metrics and how they apply to open source. And today I have Sofia with me.
Hi, my name is Sofia Vargas. I'm a program manager within Google's open source programs office. I'm also an active member in the CHAOSS community. And across both of those spaces, I work with project leaders inside and outside of Google, discussing how to implement project metrics around health and sustainability.
Awesome. Okay, to get started, let's start with definitions so that we are all on the same page. To begin with, what is DevOps? There are a lot of different definitions of DevOps, but the one that we are going to be using is an organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. In other words, DevOps is a way of using communication and automation to increase velocity and reliability to make users happy. And that brings us to Dora. Dora is the DevOps research and assessment team. In over 7 years of research, they identified 4 key metrics to predicting organizational success. And I want to point out that these are predictive metrics, which is a stronger relationship than correlation. And roughly, these metrics fall into speed and stability. On the speed side, we have deployment frequency and lead time for change. And on the stability side, we have change fail rate and time to restore service. Now, a lot of people think that these are either or metrics. However, what we find, what the research has found, is that organizations that do really well in speed also do really well in stability, because the capabilities and the systems that you put in place to improve speed go hand in hand with stability and vice versa. So with that in mind, we're going to dive into the metrics. The first one is deployment frequency, which is how frequently a team successfully releases into production. For example, daily, weekly, monthly, yearly. Now, a common mistake that I see here when people start thinking about this metric and they start trying to calculate it is easily confused with deployment volume. And so what we see is people looking at like the average number of daily deployments, which is a little bit misleading. So for example, say in the course of a month, you have one day where you do a deployment. Maybe it goes a little wonky. And so then you do 30 more deployments to try to fix all of the mistakes that happened with the first deployment. And then what we have is we have 30 deployments in this month. And when we average it out over the month, we're like, hey, look at this. We have an average daily deployment of 1. We're deploying daily. No, you are deploying monthly. So what we want to look at is how frequently we're deploying, not how much we're deploying. So next we have lead time for change, which is the median amount of time for a commit to be deployed into production. And what we want to think about here is taking a step back. This is how quickly can we develop a feature and for it to reach our customers. And so we start with the first commit because that is the first signal that we have that is consistently available. And then we end when it is deployed into production and available to the customers. The next is change fail rate, which is the number of failures per the number of deployments. So, for the rate, we have our denominator, we have our numerator. Our denominator is the number of deployments to production, and our numerator is the number of failures in production. So, for example, if you have 4 deployments in a day and one of them causes a failure, then that would be a 25% change failure rate. And a failure can be so many different things. It could be actual like 500 errors, but it also could just be like your service really slowing down and having very slow response times. And essentially, the definition of the failure is really up to each team, each organization, but it's really important to write that down and be consistent with it over time. So next we have time to restore service. So for a failure, this is the median amount of time between the deployment, which caused the failure, and the restoration. And we want to look at the actual deployment of the failure rather than the detection of it, because it's not always available, but if it is available, this tells us something about our system. So if there was a failure that is affecting our users for a month, but we just found it yesterday and we fixed it really fast once we found it, well, if you just looked at the time of detection to the time of restoration, we would think that we were doing a really great job and our users were having a really great time. But for all of these metrics, we're really considering how our users are experiencing our software delivery. And so that is why the time of deployment is a better place to start that clock, because, for a month, maybe these users were suffering. And so we have to step back and think, how do we improve our system so that we're able to better get that information in and to act on it more quickly? So again, these are our 4 key metrics. And the reason why these are helpful is because they help us benchmark against these metrics in the industry, and it helps us understand where our bottlenecks are and where we can focus our efforts for improvement where it's needed most. So those are the 4 key metrics. And now we're going to start thinking about what does this mean in open source software, which is a little bit different from all of these enterprise examples we've been talking about. Sophia?
Thanks for that overview, Dina. And the first thing I do want to talk about is your last point. What is different here? And I wanted to start with your initial definition of DevOps and understand how this can be interpreted in the realm of open source projects and communities. And the first assumption that we want to discuss is Dora and Dora's research focus has been around software development teams. And there's an implication that these teams work for companies. And while these teams might have some dynamic membership of new people coming in, people changing roles, teams changing function, there's still this idea of shared ownership and incentive because everyone works for this company. Now, in an open source project, there is no such delineation. These populations are highly dynamic, and not only are they dynamic, but expectations and incentives are highly variable. We have some volunteers, we have some paid staff, and we have other people that have uncertain amount of time and commitment to the project and may come in and out of the space. So this idea of what the organization is highly flexible and can be interpreted in various ways depending on your project. But within that and the other goals in DevOps, there are definitely some commonalities in goals, say around improving and delivering reliable and stable code, around creating a sense of shared ownership and culture. And I'd say this latter point is even more important for project leaderships because there isn't that company incentive bringing folks together. They have to foster this collaboration and culture within their extended community to ensure that folks feel engaged and are willing to take on shared ownership of the project. I would say one key difference of this focus on DevOps in the open source space is around software delivery velocity. And not to say that projects don't have this goal, but a more common goal amongst open source projects is this idea of sustainable productivity, where you're thinking about reducing the chances that your contributors or your maintainers get overworked and they burn out and then they leave the project and then the project is now at risk. So I wanted to think about how we could interpret the 4 key metrics for open source projects, starting first with deployment frequency. Depending on your project, you may or may not have a set release cadence or schedule. So here I would say pick the metric that is most reliable and easy for you to measure. Just make sure you're consistent on measuring it every time you want to benchmark yourself and improvement against this goal. But looking at, say, release, commit, or merge frequency in the project, thinking again about that highly dynamic population. Another good thing to monitor for open source projects is not just the activity, but also the distribution of that activity between contributors and maintainers. And this can be a great way to monitor what portion of your community is doing the most amount of work and how is that work being distributed, and is the current distribution a sustainable model, or do you need to, say, invest more in encouraging new contributor growth? For lead time for changes, in a similar realm, you can look at median time for a commit to be reviewed and merged. And from the perspective of open source metrics, I thought this was a great metric to look at contributor experience. In fact, there's a number of projects I've worked with that are actively monitoring this metric as a way to gauge what is the experience like for the average contributor. If they submit a pull request and it lingers for a long time, or all of their pull requests end up getting rejected, then that's not a very good experience and isn't a great incentive for them to stay engaged in the project. So we highly encourage looking at this median time for review or merge of a pull request, but also looking at how that time changes for, say, established contributors that are known entities in the population versus net new contributors who don't have the same connections and can't reach out to individuals they know. They're very much on an island here. So this could be a great way to monitor what that experience is like for net new contributors. This metric can also be an indication of issues in your decision-making process inside your project governance or project structure. So say you start with a very small project. There's only, say, 1 or 2 people that are making technical decisions in the project. But as the community grows and scales, having the same group of people review all of the changes can lead to bottlenecks and slow down that experience for net new contributors to get their pull requests reviewed and submitted into the project. So this metric could also be an indication that you need to think about your current decision-making process and governance model in the project. Has your project gotten to a large enough point where you need to start think about distributing authority and decision-making into other areas of the project? Now, for change fail rate, here we're talking about open source code and not a service. And so the idea of serviceability is not like for like when we compare this with open source projects. But I still wanted to look at these metrics and see what else we could use to measure our overall code and stability within the project and community. So one thing you could look at for change fail rate is test fail rate. Some projects have robust test infrastructure, so that could be something that you report on. Other projects do not. Maybe they're running it on a handful of laptops, and that might not be consistent year over year. So maybe a better indication of change failure rate is looking at, say, the issues that are surfaced after a prominent release and tracking how many bugs are popping up, the kinds of bugs that are popping up, and that can give you a sense of your QA process and release quality. For trying to restore a service, you could look at the median time it takes to address or fix a bug or an issue, but maybe a better measure for a project might be understanding the median time it takes to communicate that there's been a disruption in the project. So I've worked with a number of projects that don't have any sort of process here. So maybe if you're in that boat, the more basic metric is, do you have a process at all that allows you to communicate to your user and contributor population that there's some kind of issue, service disruption, or vulnerability that's come through in your project? The last point I want to make is a bit divergent from the DORA focus. And this comes back to that first assumption that we discussed around understanding how we define the organization. And with this, I want to mention that within open source, measuring the project's health and productivity around the code base is just as important as monitoring the health and sustainability of the community and population that maintains that project. So I highly recommend looking at metrics that can continually measure the health of the community around your project. So that could be looking at your contributor growth over time, your retention rate of existing community members, how long it takes for a new member to onboard or a contributor to become productive, maybe time to first commit. Maybe looking at conversion rates from your user community into your contributing population. And all of these metrics could also be an indicator of your documentation quality and completeness. Is it possible for a net new contributor to review your documentation and know how they can contribute and become productive without too much overhead? The last point I want to make is on resources. So I mentioned up front that I work with the CHAOSS community. This is a project that talks about open source metrics. We try to create a standard language and propose a set of metrics that anyone can use to monitor things like project health and sustainability. So if you're just starting this program and you would love a place to get ideas and read about how other people have implemented metrics around the open source project, this is a great place to start.
Thank you, Sophia. So now that we know about the metrics and we know why they're good and what we want to do with them, we need to start thinking about how do we measure them? Now, the DORA research used surveys, which is great if you have 7 years and thousands of teams and just a lot of data points. However, if it's just you are subject to bias. And for instance, you might be suffering from recency bias. And if you just had a really big failure and it was in TechCrunch and everybody's talking about it, you might have this like outsized idea of your change failure rate that is not reflected in the system's data. And so whenever possible, we want to use systems data. because the good news is you have all of the data that you need to calculate these metrics. The bad news is it is in 1,000 different places, which is why we started the 4 Keys project. Now, the 4 Keys project is designed to automate the collection and manipulation and calculation of the 4 key metrics. And the challenge that we faced when designing the 4 Keys project was that developers use many different kinds of tools and environments to do their work. So how do we capture the data from all of these different tools? And how do we account for tools that we don't even know about? And our solution was to create a generalized pipeline that takes in events via webhooks and ingests them into a database. Now, the default installer is designed to work with BigQuery, but you can sub in any SQL database. And data mapping is really the key of this project. And the events raw table is, in essence, a DevOps log. So as the data comes in through the webhook and goes through the ETL system, everything flows into this raw events table. So it should contain every single event related to development, deployment, and incident management. So when in doubt, stream it into the table. You don't know when you're going to need it. So from that raw events table, we create these 3 derived dimensional tables: changes, deployments, and incidents. And with these 3 entities, we can calculate our 4 key metrics. And the reason why we're doing this in SQL is so it is very easy to update the scripts and include or exclude different events from, for instance, your incidents. If you are classifying some events as incidents based on a label or maybe a certain kind of error in your logs, then you would include it in incidents. But then if you change systems, you might want to update that a little bit differently. And this is really easy to do when you are just changing your where statement in SQL. It is very difficult to do if you're trying to go back in time and pull in events that you didn't pull in to begin with that may or may not be in these different tools still. So this is why we do everything downstream, so that you can calculate and change the definitions so that you can compare apples to apples over time consistently. That brings us to the 4 Keys dashboard. This is the dashboard in the project. We actually have a new template in dark mode coming out soon, so it's going to be very fun and very exciting. And around the corners, we have these kind of daily running logs that show you how you're performing, like today and yesterday. And the thing that's nice about this is it's kind of like an early warning system of which direction you're trending. So if you have some kind of experiment in place, like maybe you had a lot of failures on your releases and now you're doing these end-to-end tests, you would expect to see your change fail rate, trending down. And so this is a really good way of giving early feedback if you're going in the right or the wrong direction. And now down the middle, we have all of the metrics bucketed over the past 3 months. So these are really kind of macro metrics. You want to step back and understand, what does this mean for your organization over time? And so that's why we have these big buckets. And they are bucketed according to the DORA research. Now, this is from the State of DevOps report, and there is a new one coming out soon. So these buckets might change a little bit. And when they do, we will also update the 4 Keys project. But I would take this with a grain of salt, because you might not have the same resources that some of these elite performers have. But what it's good for is to understand where you most need to invest effort into improving your DevOps so that people who are contributing to your project can have a smooth onboarding process and your users don't run into a lot of problems. With that, I welcome you to get started and get involved. You can try out the 4 Keys project. You install it. It's on GitHub. You just run the setup script. It's with Terraform, so it just does a lot of magical things. And we also have this blog post if you want to read more about it. And finally, if you want to ask questions or just want to chat, join us on Slack. And with that, I will say thank you very much. And thank you, Sophia.
Thank you, Dina, and thank you to our listeners.
Thank you, Dina and Sophia. for shedding light on key metrics to measure product health and also providing an out-of-box experience for open source projects. I can't wait to give 4 keys a shot. Okay, with that, it's a wrap. And you all know what it means. Yes, join us for the after party right after this. You can join us by clicking the Watch Live button in the events agenda page, and you'll be redirected to the Google Meet.
Great, and today's speakers will also be joining. We'll have some quizzes, interactive activities, and surprise guests. We hope to see you all there. Thank you.